Have you ever stood up a scene, connected a few data sources, and still felt like you were operating with blind spots, missing key signal, chasing incomplete alerts, and spending too much time normalizing data instead of investigating threats? The difference between reactive security operation and a confident one often comes down to one thing: getting the right data in the right shape at the right time. Let me introduce you to a session where you learn how to tackle these real-world scenarios by connecting the data sources that makes Microsoft Sentinel truly effective. Hello and welcome. We're glad you've joined us. I'm Jean-François Bilodeau, a Microsoft technical trainer. In this session, we'll cover Learning Path 8, Connecting Data Source to Microsoft Sentinel SIEM. Together, we'll walk through how to manage and deploy content in Microsoft Sentinel, how data connectors work, and how to bring in signals from Microsoft services, Microsoft Defender XDR, Windows hosts, CAF-based appliances, Syslog sources, and threat intelligence feed. By the end, you'll know what each connector path is, what prerequisite to plan for, and what to expect in terms of the data that lands in your workspace, so you can move from we have logs to we have actionable detection. So let's get started with this session. Here we set the stage. Defending against cyber threats is a continuous operation, and Microsoft Security Operations Platform is designed to help you collect signal, correlate activities, and respond faster. In this learning path, the focus is on connecting data sources to Microsoft Sentinel. That means understanding the connector ecosystem and making sure the security signals you rely on across cloud, identity, endpoints, and third-party appliances are flowing into your SIEM in a consistent and usable way. Let's take a look at what we'll cover. We'll start by managing content in Microsoft Sentinel. Then we'll connect data to Sentinel using data connectors, including Microsoft services and Microsoft Defender XDR. From there, we'll walk through connecting Windows hosts, bringing in common event format logs, connecting Syslog from Linux-based sources, and finally, connecting threat indicators so your detection can match, again, known bad infrastructure and entities. Here we begin with a key idea. Sentinel isn't just a place where logs land. It's a place where you manage security content. Things like rules, workbooks, and playbook that turn those logs into detection and response action. After completing this module, you'll be able to do two things. First, you'll be able to use solutions from the Content Hub to quickly bring in Microsoft-provided and partner-provided content. Second, you'll be able to connect repositories so you can deploy and manage content through source control workflows. Let's take a look at what a Content Hub solution can include. A single solution may bring in data connectors to ingest data, parsers to normalize it, workbooks for visualization, and analytics rule for detection. You can also get hunting queries for proactive investigation, notebooks for advanced analysis, watch lists for enrichment and correlation, and playbook, plus Azure Logic App, custom connectors to automate responses and workflows. When you create custom content, you can store and manage it directly inside your Sentinel workspace, or you can manage it in an external source control repository, commonly GitHub or Azure DevOps. Managing content in an external repository is powerful because it lets you update that content outside of Sentinel. track changes with versioning, and then automatically deploy those updates in your workspace as part of a controlled release process. Now we shift from managing content to bringing data in. The goal is to connect your data source to Microsoft Sentinel using the right data connectors so your workspace receives the logs, alerts, and telemetry needed for detection, hunting, and responses. After completing this module, you'll be able to explain how data connectors are used in Microsoft Sentinel, and you'll be able to describe the different data connector provider categories so you can choose the right path for each type of data source. To collect log data in Sentinel, you connect your data source using Sentinel connectors. In practice, you typically start by installing the appropriate Content Hub solutions because that solution often includes the data connector you need. And then you configure that connector so it can begin streaming data in your workspace. Here are the main categories of data connector provider you'll work with. There are connectors for Microsoft Defender XDR and the related Defender services. There are connectors for Microsoft Azure services. There are also Windows Security Event connectors, commonly through the Azure Monitoring Agent or AMA. You'll also see a broad set of vendor connectors and custom connectors, which we'll detail next. Finally, there's the Common Event Format or CEF connectors, which is frequently used for third-party security appliances that can emit CEF over Syslog. Let's dig into custom connectors. You have several approaches depending on how much control you need and how much development effort you can invest. Option includes the codeless connector platform, often called CCP, using a Logstream plugin, building integration with Logic App, using Azure Function for custom ingestion and processing, using Azure Monitor Agent for collection scenarios, or sending data via the Log Analytic API. The key here is to select a method that matches your source system, your transformation need, and your operational model. Next, we'll focus on connecting Microsoft services. These connectors help you ingest high-value signal from Microsoft security and cloud service, and in many cases, enable streamlined incident creation and investigation workflows in Sentinel. After completing this module, you'll be able to connect Microsoft Service data connectors, explain how connectors can automatically create incidents in Microsoft Sentinel, and activate the Microsoft Defender for Cloud connector in Sentinel. Before you turn these connectors on, it's important to plan prerequisite and outcome. For Microsoft Defender for Cloud, you'll need the right permission on the workspace, specifically read and write permission. Also, keep in mind configuration detail. For example, the Windows security events via AMA connectors create data connection rule or DCR. And when we talk about incident creation, a common pattern is that incidents are created from alert data, often specifically from alert stored in security alert table. So understanding where alerts land helps you understand what can drive incidents. Let's take a look at Microsoft Defender for Cloud integration. There are two connectors available. The first is the subscription-based Microsoft Defender for Cloud, sometimes labeled as the legacy connector. This connector streams your security alerts from Defender for Cloud into Microsoft Sentinel, specifically into the security alert table. The second option is the tenant-based Microsoft Defender for Cloud connector. This connector also streams your security alerts into the security alert table in Sentinel, but it can additionally stream into Defender XDR alerts and incidents. So your operation model includes working in the Defender portal as well as Sentinel. The tenant-based approach supports that broader integration. Here we gain deeper insight into Microsoft Entra ID by connecting audit logs and sign-in logs to Sentinel. This helps you investigate identity-focused scenarios like suspicious sign-in pattern, changes to privilege role, or risky user activities, using data that's already central to many incident investigation. This is marked as an optional topic, but it's one of the most commonly deployed connector in real environments. Beyond identity and Defender for Cloud, there are many Azure-focused solutions that include data connector. Common examples include the Azure Activity Logs, Azure DDoS Protection, Azure Firewall, Azure Key Vault, Azure SQL Database, Azure Web Application Firewall, or WAF. These connectors give you visibility into control plane action, network control, and data layer event signals that are often essential for cloud threats and detection. Next, we connect Microsoft Defender XDR to Sentinel. This integration helps you bring in Defender signals and, depending on configuration, enable Sentinel to work with Defender's alerting and incident ecosystem more seamlessly. After completing this module, you'll be able to activate the Microsoft Defender XDR connector in Sentinel. To enable it, you typically need security administrator permission in the tenant for Microsoft Entra ID. In many environments, this is enabled by default when Sentinel is onboarded to Defender XDR. And if you onboard Sentinel to the Defender portal and you're licensed for Defender XDR, the connection is automatically established and the data connector is set up for you. When planning Defender-based connector, you'll commonly use Microsoft Defender XDR, Microsoft Defender for Office 365, and Microsoft Defender for Endpoint. A key point to emphasize here is that these Defender connectors generally send alert data into Sentinel, and that alert data can then be used to generate incident depending on how you configure incident creation rule and how you want your SOC to operate. Let's take a look at what the Microsoft Defender XDR connector provides. It's installed as part of the Microsoft Defender XDR solution and lets you stream advanced hunting data. It's also helpful to remember what's included in the Defender XDR suite: Microsoft Defender for Endpoint, Defender for Identity, Defender for Office 365, Defender for Cloud App, Defender Alerts, Defender Vulnerability Management, Microsoft Purview, Data Loss Prevention, and Microsoft Entra ID Protection. Once connected, you can expect a wide range of data types to become available, including core incidents and alert tables like security incident and security alerts, plus a broad set of hunting and telemetry tables, such as device events, device file events, device info, and many more. In addition to the major Defender workload, Sentinel provides built-in connectors for other Microsoft Defender solutions. Examples include Microsoft Defender for Threat Intelligence and Microsoft Defender for IoT. These connectors broaden your visibility, bringing in intelligence context and operational technology signal where those are part of your environment. Now let's focus on Windows host. Endpoint and server security events remain foundational for investigation. So the goal here is to connect both Azure-based and non-Azure Windows machine so that their security events can be collected and analyzed in Sentinel. After completing this module, you'll be able to connect Azure Windows virtual machine to Sentinel, connect non-Azure Windows OS to Sentinel, and configure the Azure monitoring agent to collect security events. When you plan Windows security event ingestion, you'll typically use the Content Hub solutions as part of your entry point. Common solution includes the Windows security events via AMA, Windows Server DNS via AMA, and Windows forwarded events. These solutions install the required data connector from the Azure monitoring agent and uses data collection rules, DCR, to define what gets collected. And just as a quick reminder, AMA stands for Azure Monitoring Agent. Here we look at the Windows security events via AMA connector and why it's commonly recommended. Benefits include being able to manage collection settings at scale, reusing the Azure monitoring agent across multiple solutions, improving security and performance, and saving costs by using the data collection rule. There are also limitations to be aware of. Some feature may be available only in public preview. In terms of requirement, you'll be working with DCR, and for non-Azure VMs or device, you'll typically need Azure Arc. Let's take a look at what it looks like when you install this from the Content Hub. You'll install the Windows security events via AMA connector solution, review the prerequisite, and then configure collection through a data collection rule. Now we focus on selecting the resources that the DCR will apply to. For non-Azure machine, they must be connected through Azure Arc. And when you add machine at DCR resources, any machine that doesn't already have an Azure monitoring agent, whether it's Windows or Linux, will have the agent installed as part of that onboarding process. Here we examine the DCR configuration itself. This is where you specify exactly which Windows security event to collect and how they should be delivered into your workspace, giving you centralized control over volume, cost, and investigative value. Next, let's bring in log from external security solution using the common event format or CEF. This is a common scenario where you're integrating network, firewall, or third-party security appliances data into Sentinel. After completing this module, you'll be able to explain the CEF connector deployment option in Sentinel, and you'll be able to explain the difference between the CEF and Syslog connector. So you can choose the right approach for your source system and for the level of parsing you need. Here's the typical deployment model for CEF ingestion. You deploy a Syslog forwarder server that acts as a bridge between your appliance and Sentinel. That forwarder is a dedicated Linux machine with the Azure monitoring agent for Linux installed. Many vendor-specific Sentinel connectors rely on the CEF connectors behind the scene. You can deploy this forwarder in Azure or on-premise, and importantly, CEF is generally recommended over basic Syslog because CEF provides parse message data, which reduces the amount of parsing you need to do during queries and investigation. This architecture diagram illustrates how CEF logs collection data using the common event format using AMA connectors currently in preview. Your security appliance sends Syslog to the forwarder uses its Syslog daemon and the Azure monitoring agent for Linux to collect and securely send those events to Sentinel, where they're parsed and enriched for analysis. Let's walk through the connection process. You start by creating a data collection rule and then use the link on the connector page to get a script. You run that script on the designated Linux machine that will act as your forwarder. That machine can be physical or virtual, could be on-prem, in Azure, or another cloud, as long as it can receive the Syslog traffic from your security solution. When you run the script, it installs the Azure monitoring agent for Linux and configures it to listen to KEF messages from the built-in Linux Syslog daemon running on TCP port 25226. It also configures secure transport over TLS to your Sentinel workspace, where the messages are parsed and enriched. At the same time, the script configures the Syslog daemon, such as rsyslog or syslog ng, to listen to Syslog messages from your security solution on TCP port 514, and then forwards only the messages identified as KEF to the agent locally on TCP port 25226. Now let's move to Syslog ingestion. While KEF is a structured format layered on top of Syslog, many environments still needs to connect to plain Syslog events from Linux hosts and appliance and then parse them as needed into Sentinel. After completing this module, you'll be able to describe the Syslog data collection rule configuration in Microsoft Azure, understand how the Azure monitoring agent for Linux is deployed, create and configure a DCR to send data to Sentinel, and create a parser using KQL in Sentinel. And then we'll reinforce that creating and configuring the DCR is the central step that ties collection to your workspace. Here's the overall approach. You stream event from your Linux-based Syslog supporting machine or appliances into Sentinel using the Azure monitoring agent for Linux and data collection rules. The host native Syslog daemon collects local event of specified type and forwards them locally to the agent, and the agent streams them to your log analytic workspace. From a how it works perspective, Syslog is a common Linux event logging protocol where the Azure monitoring agent for Linux is installed. It configures the local Syslog daemon to forward message to the agent on TCP port 28330. The agent then sends those messages to your log analytic workspace over TCP 443 using HTTPS. Once ingested, the events are parsed into entries in the Syslog table, which you can query using Sentinel under logs. This diagram shows the Syslog collection architecture from a single source. The key takeaway is the flow. Source generates Syslogs, the agent and local daemon cooperate to forward events, and the workspace receives and stores those events for Sentinel queries and detection. Here we focus on onboarding Azure Linux virtual machine. When you add Azure Linux VM as resources in Syslog data collection rule, the Azure monitoring agent is deployed. So to connect an Azure-based Linux VM, you add it as a DCR resource, and the platform handles agent deployment and association so events can start flowing. For non-Azure Linux host, the approach changes slightly. You provision those machines using Azure Arc. There are more steps involved compared to Azure native VM, and you generally need to manually install the agent as part of bringing that host under management so it can participate in DCR-based collection. Now we configure what actually gets collected. The data collection rule will only collect events that match the facilities and severities you specify. This is a critical control point. It lets you balance investigative coverage with data volume and cost, while ensuring that the event you do ingest are the ones your detection and hunting workflow actually need. Let's dive deeper into how Syslog data is parsed once it's ingested. The Syslog connector writes events into the Syslog table, and unlike the KEF connector, the message payload is stored as a single string in the Syslog message field. That means parsing is something you must do manually. You must handle. One effective approach is to create a reusable parser using KQL. In this example, a function named myParser is created. The query starts from the Syslog table, filters on a specific process name such as squid, and then uses the extract statement to pull structured field from the raw Syslog message text field like URL, source IP address, username, remote port, and domains are extracted and made available as individual columns. By saving this query as a function, you only need to write the parsing logic once. After that, you can refer myParser just like any other table in Sentinel. In practice, you create the query in the log experience, select save, choose function, and then assign a function name and alias. From that point forward, calling myParser gives you consistently parsed Syslog data without repeating the parsing logic in every query. Next, we shift focus to threat intelligence. Dissecting threat indicator allows Sentinel to match log data against known malicious IPs, domains, URL, and file hashes, turning raw telemetry into actionable detection. This capability helps bridges the gap between external intelligence and internal telemetry, enabling detection that are informed by what's happening beyond your own environment. After completing this module, you'll be able to install the Threat Intelligence Content Hub solution, configure Threat Intelligence Connector, use analytic rules, hunting queries, and workbook, and view threat indicators in Sentinel logs through the Threat Intel Indicator table. These skills are foundational for enriching detection with external context and improving investigation efficiency. Here we outline what the threat intelligence solution provides. It includes multiple data connectors such as taxi-based feed, the Threat Intelligence Upload Indicator API, Microsoft Defender Threat Intelligence, and integration with third-party threat intelligence platform. Analytics rule use these indicators to generate alerts and incident where match occurs in your log data. Workbook summarizes indicator activities and trend, while hunting queries allows analysts to proactively search for related activities. Together, these components help operationalize threat intelligence within Sentinel. Installing the Threat Intelligence solution from the Content Hub gives you access to 5 built-in connectors. These include connector for Threat Intelligence Platform, the Upload Indicator API, Microsoft Defender Threat Intelligence, premium Microsoft Defender Threat Intelligence, and taxi feeds. Once installed, these connectors make it possible to ingest indicators from multiple sources into Sentinel in a standardized way. With indicators flowing in, the next step is enabling detection. Threat Intelligence Analytic Rule Template allows you to create alerts and incident when log event matches known indicator. By enabling and tuning these templates, Sentinel can automatically surface activities that align with known malicious infrastructure, helping analysts focus on high confidence threats. In addition to built-in connectors, you can also send indicators directly to Sentinel using the Upload Indicators API. This allows application or threat intelligence platform to push indicators in Sentinel using REST-based method. This approach is commonly used when integrating custom tooling or centralizing threat intelligence platform that already manage indicator lifecycle. Once indicators are ingested, they're available in multiple places. You can view them directly in the Threat Intelligence Blade or query them from the Threat Intel Indicator table in Logs. At this point in the session, everything comes together. This demonstration shows how logs are connected to Sentinel across multiple sources, reinforcing how connectors, data collection rules, and Content Hub solution work together in practice. In this demo, let's start connecting data to our Sentinel using Data Connector. We've already got our Sentinel workspace open over here. Let's navigate to the Content Management Hub. Let's select the Content Hub. And what we're going to do over here is we're going to connect Microsoft Defender for Cloud. Let's search for it. Defender for Cloud. It's already installed, but not configured. So let's select it. And let's go down to Manage. Here are our connectors. Let's select the subscription-based Defender. Let's configure it. And let's scroll down. What we're going to do here is connect it to our subscription. All I need to do is select the subscription, connect it, and optionally choose whether we want to enable bi-directional sync between Sentinel and Defender for Cloud. Done. We have connected Defender for Cloud. With Sentinel, we can see status connected. Next, let's connect an Azure activity data to Sentinel. We'll go back to our Content Hub. Let's search for Azure Activity. Let's select it. Click on Manage. Let's select the Azure Activity Connector. Open connector page so we can do the configuration. And let's scroll down. We're not going to be able to do the full connection because we need to grant access to Sentinel to Azure Activity. And to do that, we'll set up a policy. We'll do that at the subscription level. We're not going to include everything. We're going to connect our log analytic workspace to Azure Activity. Select. Remediation will let Azure do the heavy lifting. Create a remediation task to ensure that the connection can take place. For that connection to take place, identity will be necessary. So in the next step, we're going to select a manage identity and launch the creation. Now that this remediation has taken place, we can connect our Azure Activity Log to Defender. Next, let's connect virtual machines to Sentinel. We'll begin by creating a virtual machine in the Azure portal. So let's go ahead and create a new resource. In this case, we're going to create a Windows 11 virtual machine. And let's pick, there we go, Windows 11 Enterprise. We'll go to slightly older version, 23H2, and create. We'll need to select a subscription, resource group. We'll pick an existing resource group. Let's give it a distinct name. AZWin01. And where do we want to run it? We don't need infrastructure redundancy. Let's select an adequate size for this one. A D2S V4 should be adequate. And finally, username and password for the administrative account. Let's just create a sample administrative name, password, strong password, of course, and confirm that we have an eligible license for Windows 11 available on hand. Let's launch the creation. It'll take a moment or two to create the VM. Deploying a VM deploys a lot of resources. And there we go, we are done. And now we've got our first virtual machine deployed. It's already got the Azure Monitoring Agent installed. So now we're ready to connect it to Sentinel. Let's do that next. All right, back in Sentinel, let's now connect our virtual machine to Sentinel so we can start receiving security events. We're going to head down to the Content Hub and let's search for Windows Security Events. Let's find the connector. There it is. It's already installed, but it needs to be configured. Let's click on Managed. And we're going to connect to our machine using Windows Security Event via AMA, Azure Monitoring Agent. To do that, we're going to need to create a data collection rule, DCR. Let's go ahead and do that right now. Create data collection rule. We're going to give it a name. Let's just call it AZWin DCR. And the subscription resource group in which the machine and the DCR will exist. Next, which machine or machines do we want to connect to this data connection rule? In this case, we'll pick the VM we've created just a moment ago. Collect. We're going to pick up every security event. And next, create. We've set up our data collection rule. We've connected to the Azure Monitoring Agent on that VM. Now, Sentinel can receive telemetry from that virtual machine. If needs be, we can change the data collection rule, going back to the collector. But let's refresh, make sure that we can now see our virtual machine in here. There's the rule that we've created. Let's recap what we've covered in this learning path. Microsoft Sentinel provides a wide range of data connectors to bring in logs and alerts from Microsoft services, Defender solution, Windows and Linux hosts, third-party appliances, and threat intelligence source. We explored how Content Hub solution bundles connectors, parsers, workbook, analytics rule, hunting queries, notebooks, watch lists, and playbook. We also emphasized the role of data collection rule in managing collection at scale, improving performance, and controlling costs. Finally, we looked at how threat intelligence and Microsoft Defender integration enhances detection and investigation capabilities across the platform. This concludes our session. There are many ways to complete your learning journey. We encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn at aka.ms/learn.